Here we are again in the PLC Professor's Workshop. We're going to continue the previous lecture, which was on the one-shot instruction, my favorite instruction. And that's probably why I rattled on so long. Typically, I try to keep it under 30 minutes. When I saw that it was approaching 45 minutes, I decided to stop and then continue on. It's all one lecture. We're just delivering it in two pieces. And I'll be honest with you, this subject is not a one-day learning process. You're going to have to be dedicated to a lot of hours of studying and playing with the software and pondering PLC characteristics if you want to become proficient out on the shop floor working with PLCs. There's a reason why it pays so well. I remember one day, and by the way, I don't do much of the engineering anymore. I still do some, and I do really like engineering. I really like being out on the shop floor troubleshooting. One day I was out on the shop floor commissioning a system, and I got 7 calls from 7 different recruiters for 7 different positions. It got so bad I had to turn my phone off to avoid the interruptions. And the demand for people that work on PLCs is not diminished. It has actually grown exponentially. And it's kind of a double-edged sword because people who do this kind of work are leaving the field faster than they're coming into the field, and the demand is increasing. So you figure it out. That just means that the wages are going to keep rising simply because there aren't enough people to do the work. Let's continue with the one-shot instruction. I may have thought that the subject of the one-shot instruction would be a one-video discussion. However, since I went off chasing rabbits, we had to end that first discussion, and now we're starting the second discussion, which is roughly page 182 or 183 or something like that in your manual. And it's titled, Which Comes First? And right off, I said, under no circumstances do you want to rush through this next sequence. Absorb every little detail that you can, and it will serve you well for the rest of your career with controllers. That's because we're going to examine the behavior of the one-shot very closely. In your program, I had you move this. We'll put this into the edit mode. We'll drag this over here, so now we have the one-shot count right after the one-shot. So it's counting the actual true out, okay, because that's what a counter does. It counts the false to true transitions. And then after bullet, we had a one-shot out count. And after count, we had a bit called scan sensitive. And what we're going to do here is demonstrate the relationship between the post conditions to the preconditions of the one-shot. And we call this scan sensitive because it makes a difference in what order these were true based on scan. So new, main program, create. Finalize all edits. And we'll drag this down a little and go back to the watch panel. Well, we need a little more than that. But we need enough to be able to see bullet, hammer, one-shot count, and then scan sensitive and trigger. I also probably had you set these back to 0, so you can just click on them, 0, hit enter, and they're reset. We could have also added logic that allows you to just click on something and it resets them to 0. We had you toggle the trigger to 0 and record the new values. In the manual, I show 2 truth tables, if you like. They're not really truth tables, they're just little forms for you to fill out. the first one shows everything set to 0, toggle trigger to the on state, and then fill in the blanks. So as we look there, bullet is 0, hammer is 1, one shot count and one shot out count, which that's not what mine is named. I'll change it here in a minute so it looks the same. The one shot count is 1, and the other counter, which is an add instruction in this time, but remember I'm doing things a little bit different just to give you another perspective, it's at 0. Scan sensitive is at 0, and the trigger is on. When you look down your list, it should be 011001. Now I'm going to change the name of this. While we're running, I'm going to go to edit. I'm going to edit the properties. And we called ours one shot out count, so I'll add OUT underscore, and I'll put the vowels in there for the sticklers, and I have to lower this in order to get to apply and OK. Now we drag it back up. So see, you can edit the tag name online because it really doesn't change anything in memory. It changes the tag name, but it doesn't reposition anything in memory, which is a little bit more involved. You would at least have to go into the edit mode to do that if you're going to reposition and restructure your data table. Okay, did the one-shot hammer go to the true state? Well, yes it did. You can see right there that it's on, so it had to have gone to the true state. How can you determine if the one-shot instruction had a true run condition out? Because of the count up. If you look up the instruction help on a count up instruction, and get used to doing this on a regular basis as you're learning. So we want, I think it's timer counter right there. Timer counter instructions, count up, execution. Okay, run condition in is true, so we'd have to go to the flow chart if we wanted to do that. Or we can look here, run condition. When the run condition in goes from false to true, the count up bit goes on. If it goes false and then true again, then it counts again. This clearly shows you that this instruction increments the counter data type by 1 for every false to true transition. We know that the condition out of this one shot went true for one scan because we have a 1 here. Now this instruction is false because scan sensitive, that bit memory is off, therefore this is false, so bullet never came on. If bullet had come on, this would have counted up by 1. We know this from the previous logic before we added this bit that isolated the one shot from bullet with a post condition, something that's after the one shot. Remember that the count up in no way interferes with the logic, and neither does the add. It simply does something, but the true goes right through it and the false goes right through it. With tags at the last state, toggle scan sensitive to the on state and record the new values. This is very critical that you did this in the right order without changing any of this. So now watch this value and everything down here when I do this. Now, did that increment by 1? No, it did not. So now let's go down and record the values. Bullet, of course, is going to be off because it'll never show on. Hammer is on because we never turned it off. One shot count is 1. One shot out count is still 0. Scan sensitive is on, or 1, so that is a change. And the trigger is still on. Reading from top to bottom, 011011. If you compare the two charts, only thing that changed was you turned on scan sensitive. But notice it had no effect whatsoever on bullet. That's the important thing to note. Did OTE bullet go to the true state? No. Does the rung look to be true? Yes, it does. If you pull out the count up and the add, this looks true, that looks true, and that looks true. But remember, this is a read and write, so you're looking at the state of that bit, on or off. This is never true or false based on the highlight, because you would never see it, it's too fast. But if you see this highlighted, that means it's on. Just like if you saw this highlighted, it would be on. You won't see the true-false state of a one-shot instruction. You'll only see on or off of the storage bit. Does the rung look to be true? Yes, it does. Is the rung true? No, it is not, because the one-shot instruction, hammer, has a false out. How can you determine whether or not the OT instruction had a true rung condition out? We would know it because the add instruction would have incremented by 1, which we clearly demonstrated in the last piece of logic and discussed in the former video. With the tags at last state, toggle trigger to the off state and record the new values. So we're going to the off state here, toggle it off. Now record the values. Bullet is off, and you never really see that going anyway. Hammer is off, that's a change. One shot count is still 1. One shot out count is still 0. Scan sensitive, that's still on, that's 1. And trigger is 0. So reading top to bottom, 0, 0, 1, 0, 1, 0. Did this change in the state of trigger result in any other state changes? I would say no, except that one thing we don't have in this chart is, well, we do, we have hammer. So hammer is the state of the storage bit for that one shot. I was thinking for a moment I might have missed something here, but no. You're looking at the changes in states. With the tags at the last state, toggle trigger to the on state and record the new values. Before you did that though, remember that scan sensitive is now on. It was not on the last time we did this. Okay, this is what we're working up towards, is the difference between when the post conditions are off or on when this goes true. So we'll toggle this on. Now look, we got a one shot out count of 1 because this was true. So when the true one shotted out of this instruction, incremented the counter data type. This is true, true out. Turn that bit on, incremented that by 1. Next scan, this is true, but this is already on, false out, no count up, false out, etc. Okay, now we want to record on the next page. We want to record bullet is a 0, of course. We never see that go on, but we know it went on. Hammer is on. One shot count is 2, it incremented. One shot out count is 1, it incremented. Scan sensitive is still on, we did not turn it off. And trigger is still on, we did not turn it off. So top to bottom you would read 0, 0, 2, 1, 1, 1. Compare the current states and accumulates with the results in an earlier step where you toggle the trigger to the on state. If you look at the previous 0, 1, 1, 0, 0, 1 and compare it to 0, 1, 2, 1, 1, 1, did the one shot count increment? Yes. Why? Because the trigger went from false to true. Because it was false on the previous scan, hammer was cleared to 0. So when it went true, it made the one shot true and set the storage bit hammer to 1. And then rung out true, count up incremented, rung out true to scan sensitive, it's true, rung out true to bullet, sets it to 1, rung out true to the add instruction, and then incremented it by 1. Next scan through, trigger is true, but because hammer is already 1, one shot out is false. On the next scan and all subsequent scans, as long as trigger is 1, no count up, scan sensitive is true, but it's still false out, so the rest of the rung does not execute. So we answered these questions. How many times did bullet change state? Well, it only changed state once, even if you pull the trigger again. In other words, if in the previous, when this was off and you pull the trigger, we did not get a one-shot count out. The bullet did not change state. If this counts up, then we know the bullet changed state. There were 2 instances of pulling the trigger, but only one in which the bullet changed state. And that was when the post condition was true before the precondition was true. So when you're doing one-shot instructions, everything from the one shot over to whatever action you want has to be true before the precondition goes true. Did you actually see with your own eyes the bit in memory bullet change state? No. Why? Scan time is roughly 20 microseconds. We can go verify that. It's going to be, it might be a little longer than that, simply because we have a little bit more logic in there. So if we go to monitor, yes, you can see it's 20 microseconds, 20, 22 or so, but still roughly 20 microseconds. The state of which bit in memory determines the true-false run condition out of the one-shot instruction addressing the bit in memory hammer. The bit hammer. That's what determines the true-false run condition out of the one-shot is the state of the bit hammer in memory. Both trigger and hammer address, point 2, bits in memory that are not influenced by outside factors such as non-synchronous input data types updates during the program scan. If the bit scan sensitive is not on when the trigger goes to the on state, will the bit bullet change to the on state? No, it will not, because if scan sensitive is off, then that instruction is false, and out of that trueify instruction that reads scan sensitive, if that bit is off, then it's going to put out a rung false condition and no bullet. Generally, would you say that the bit addressed as scan sensitive must be in the on state at or when the trigger goes to the on state to fire the bullet? Yes. When the bit in memory bullet changes to the on state, it stays on until what happens? The next program scan. On the next program scan, and you have to have at least one scan with trigger off to reset the hammer, and then on the subsequent scan next, the trigger could go on again, could go true again, and the hammer could be true out and it could fire a bullet again. The fastest that you can run a one shot is on one scan, the one shot executes a true out. On the next scan, the preconditions in front of the one shot have to be false to clear it, and then it has a false out. And then on the next scan, you could go back to the trigger being on again. Now, one thing that I stated here that was tight, generally, would you say that the bit address is scan sensitive must be in the on state at or when the trigger goes to the on state to fire the bullet? When I say this has to be on before, it could be on before or at. So if on one scan this is false and this is false, but then on the next scan something happened before the next scan where both of these are turned on, then this goes on, true out, sets this to 1, true out, count up. Because that is also true, then you get the bullet and you get the add. The way I read it and the way it's stated in your manual is the clearest, the way to state it with the most clarity. Depending upon your level of programming experience, it may behoove you, benefit you, to repeat this lab project on occasion until the one-shot instruction is as familiar to you as a wrench is to a mechanic. If you do not think about what or how a wrench functions, you just grab it and use it, second nature. The one-shot has to be at that level in your head for you to effectively use it.